Hello students, and welcome again to another video. Today we're going to be discussing predicting outcomes of chemical reactions. And basically there's 5 major types of reactions that we're going to cover in this class. And down here is the 5 types. And we spent time in class and we drew all this out. So you're going to want to take notes and draw these circles out and draw all these pictures and label them based on these sides over here. I'm not going to draw it all out for you in this video. I'm just going to talk about it, okay? But that's what we did in class. So a combination reaction is we're taking 2 separate entities and we're combining them to form something new. So in this example, you could think of iron and oxygen forming iron oxide, right? Or iron 3 oxide, if you want to be specific. And that's rust, okay? Like we have Mater off of cars. We've got his paint comes off and his iron is now exposed to the air. It's going to react slowly over time and it's going to turn into rust. And the rust is completely different now, has different characteristics than both of these separate. So once they combine, it's a new substance, it's a new compound, okay? Right. Decomposition reactions, we are taking a compound and we're breaking it into its elemental parts, or it could even be compounds that are breaking apart, okay? And an example of this could be mercury oxide. We have mercury and oxygen, and we apply heat. Mercury and oxygen separate. The oxygen escapes as a gas, and the mercury is left at the bottom of the container. Okay. And there's a picture in the book that we're going to explain and talk more about that. And we're going to go more in depth on all of these. We're going to spend time on them individually. We're just doing an overview. Okay. And then we have what we call a single replacement reaction, where generally these occur in aqueous solutions. So we're going to have a dissolved substance, and we're going to put something into that solution, and it's going to replace one of these 2 substances. And in this reaction, A is the one that's being replaced. So C is coming over and bumping it out, and A is now going to become it back to its elemental form other than before it was in a compound, okay? And we'll talk about this. We're going to spend time talking about the activity series. We're going to discuss why is it that A is taken and not B. Okay, and if a reaction even occurs, right? Is there a chance that C could not react with A or B? Yeah, there is, and we'll discuss that. The next one is the double replacement reaction. Now in this class, we're going to be focusing just on aqueous solutions. So we're going to have generally they're a clear substance that we've dissolved for both of these, and when we mix them, okay, they're going to switch places, and we're going to predict which one forms a precipitate and which one forms a solid. Which one forms a precipitate, which is a solid, and the other one it will remain aqueous and stay in solution, okay? And I'm just giving you an overview, okay? It's hard to understand all that's going on, but we're going to go in depth, okay? After you've studied all of this, come back to this video and watch me explain it again, and it will all start making a little more sense, okay? So what's happening is A and C are going to stay the same while B and D switch places. You notice that B and D are the ones that switch. Right, and then we're going to make predictions on what happens. So basically, we're pouring 2 things together. Something is changing. There's a chemical reaction occurring, and we have to predict what's going to change in that reaction. Okay. All right. And lastly, we're going to talk about our favorite ones, and that's combustion. If you've ever gone camping in the summer and you've stared at the fire and you're wondering what is going on, why is this happening? Well, it's because log is serving as a fuel, it's reacting with the air, and it's forming carbon dioxide and water, okay? And if you notice this equation, it's balanced. They included the second one. It's balanced, and it's showing that there is methane, which is what is the gas that we use in our classrooms, okay? And we combine it with oxygen in the air in a Bunsen burner, and we light it on fire, we get that activation energy to get started, and then carbon dioxide and water is formed, okay? We'll spend a great deal of time talking about this, going through it, okay? These are the 5 major types of reactions, and this is just an overview, okay? We're going to go in depth on each of these, and I want to make a video on each of them, okay? Thank you so much for watching.